So we have our problem, d cubed minus 6d squared plus 11d minus 6, quantity of y equals to f of x. So we are asked to obtain a formula for a particular integral. So at first, we will find the roots for this equation. So we have m cubed minus 6m squared plus 11m minus 6. For the equation d cubed minus 6d squared plus 11d minus 6, then y is equals to 0, since f of x we equate it equal to 0. Then we will have these roots, m cubed minus 3m plus 2 and m minus 3, which is the factor of m cubed minus 6m squared plus 11m minus 6 equal to 0. So finding the roots, we have m squared minus 3m plus 2 equal to 0 and m minus 3 equals to 0. So finding the value of m minus 2, m minus 1 equal to 0 and m is equals to 3. So we have m is equals to 2, m equals to 1 and m equals to 3. So we have 3 roots, 2, 1 and 3. So we will get y equals to ex u1 plus e to the 2x plus e to the 3x u3. Since we have the roots 1, 2 and 3, then using the variation of parameters, we will get e to the x u1 prime plus e to 2x u2 prime plus e to the 3x u3 prime. So deriving this equation, so we will get ex u1 prime plus 2 e2x u2 prime plus 3 e2x u3 prime equals to 0. Again, deriving the equation, so we have ex u1 prime plus 4 e2x prime plus 9 e3x u3 prime equals to f of x. Since we have 3 roots, so we have only 3 equations. So now we will find the particular integral using the Cramer's rule. So from the three equations earlier, we will get this w equals to this equation. So now we will use the Cramer's rule. So I will explain to you how to get it using the Cramer's rule. So first, e to the x times 2 e to the 2x times 9 e to the 3x, which is this e to the x, 2 e to the 2x, and 9 e to the 3x, minus e to the x, 3 e to the 3x, and 4 e to the 2x, minus this e to the x, 3 e to the 3x, and 4 e to the 2x. So here, minus, if we have extension here, e to the x, e to the x, and e to the x. So again, plus another quantity for this equation, e to the 2x, 3 e to the 3x multiplied by, if we imagine here, e to the x, which is here, then minus again, different direction, e to the 2x, e to the x, minus 9 e to the 3x. So it's just simple. So again, e to the 3x plus e to the x for e to the 2x, minus another e to the 3x, 2 e to the 2x, and e to the x. So we will get our final answer, 18 e to the 6x minus 12 e to the 6x plus 3 e to the 6x minus 9 e to the 6x plus 4 e to the 6x minus 2 e to the 6x. And using Cramer's rule earlier, we will get 2 e to the 6x. So this is our w. So now we will again find u1 prime, u2 prime, and u3 prime, again by the Cramer's rule. Now we will solve for our u1 prime, u2 prime, and u3 prime. So our u1 prime, we let the first line equal to 0. Then e to the 2x to e to the 2x. The same from what I explained earlier. So we will get e to the 5x f of x using Cramer's rule, which I explained earlier. So you have to learn Cramer's rule from what I've explained earlier. So again, from the u2 prime, e to the x, first line, now we let 0 on the second line. Then e to 3x, 3 to 3x, and e to 3x. So again, using Cramer's rule, from what I explained earlier, from the w, negative 2, e to the 4x, f of x. And from the u3 prime, again, we let from the third line 0. So we will get e to the 3x, f of x. So now we have our u1 prime, u2 prime, u3 prime. And we will now divide this by w. So we get, so we now have u1 prime equals to e to the 5x from what we get from the Cramer's rule over 2 e to the 6x from our w. u2 prime equals to negative 2 e to the 4x over 2 e to the 6x, and the u3 prime equals to e to the 3x over 2 e to the 6x f of x. So now you will now get our u1 and u2 and u3. So we will have u1 equals to 1/2 integral of e to the negative x f of x dx. u2 negative e to the negative 2x f of x dx. And the u3 equals to 1/2 integral for e to the negative 3x f of x dx. So we will now get our final answer. So we have now our final answer. From the equation y equals to ex u1 plus e to the 2x u2 plus e to the 3x u3. This is the form for our final answer. So from what we get from the last u1 and u2 and u3, so we already have the value for this. So we substitute u1, u2, and u3. So we will get y equals to e to the x over 2 integral of e to the negative x f of x dx minus e to the 2x integral of e to the negative 2x f of x dx plus e to the 3x over 2 integral of e to the negative 3x f of x dx. So this is our final answer.